Hello, welcome back to the continuation of the solution for problem number 1, AP Calculus Free Response Section 2018. Last time we have solved the subpoint A, and today I will try to solve for you subpoint B. So let's review. During the time interval t between 0 and 300 seconds, there are always people in line for the escalator. How many people are in line at time t equals 300? I'm going to move back to a section where I can show you what I'm writing down. That's what we did last time. We came up with a general equation describing a quantity at a time t as being as consisting of Q0, quantity at time 0 when the process starts, the quantity that's added throughout time, and the quantity that is getting out throughout time. So for our specific problem, the number of people at time t is going to be given by adding, let's say, these three values: the number of people at time 0, the number of people entering, and obviously subtracting the number of people that will get out. We have solved part A of the problem, and we discovered that the total number of people entering the escalator line within those 300 seconds was 270. Now we'll be moving in solving part B of the problem. Again, just to refresh a little bit your memory, there are always people in line for the how many people are in line at time t equals 300. It's clear that we have to use the whole equation. So let's start with the initial equation I have established. Any quantity at time t will be the quantity at time 0 plus the quantity that's added throughout time minus the quantity that was eliminated throughout time. So at time 300, I have Q of 0 plus the quantity added, or the number of people added up to 300 seconds, minus the number of people that will exit at 300 seconds. Let's go back with the substitution we already know. At time 0, there were already 20 people on the escalator line. After 300 seconds, we discovered that there were 270 people added, and the people that will exit the escalator will be given by the equation integral from 0 to 300, the rate at which the people are getting out, dt. Now, this integral is something I can do by hand, so the number of people at time 300 that would have been on that escalator line is 290, just by adding these two quantities, minus 0.7 t between 0 and 300. Or, number of people at time 300 is going to be 290 minus 0.7 times 300, which is 210, minus 0 doesn't, it's 0. So the number of people after 300 seconds that will enter that escalator and work in line is actually at exactly second 30 is 80 people. Again, don't forget, or persons. We need to write the units. Let's go to the next part of our problem. Point C, for time t greater than 300, what is the first time that there are no people in line for the escalator? Okay, so if I try to solve this problem, point C, then I would like to see when is the first time the people are not people on the escalator. So I'm going to do something that I will consider time t after 300 seconds. So I know that the number of people at time t after 300 seconds will be 80 people at 300 seconds. And because if you remember from the original equation, let's take a look and see now in line. There are no people entering, as you can see right here, there are no people entering after 300, time t equals 300. So going back to the notes, since I have no a of t, I just have to take people out. So e of t. Let me write it again, this time replacing e of t with what actually it is. It's integral from 0 to a time t, whatever. The rate at which people are exiting, and dx right here. So this quantity, time t, should be at minus 0.7x between t and 0 is 0.7 t. Now this quantity I need to make it equal to 0, so that will help me to figure out what the time is. Q of t equals 0 results that at minus 0.7 t equals 0. Or if I want to solve that equation, I end up with 0.7 t equals 80 t. It's 80 divided by 0.7. So 80 divided by 0.7 will give me the time. I'm gonna estimate this one using a calculator, so I will add a calculator, and right here I'm gonna divide 80 by 0.7. So the time, it's 114 seconds, 0.286 after 300. Let me write it here. The time t is 114.286 seconds after 300 seconds. Since the beginning of the process, since we started actually estimating the number of people in line, it means that the total time t is going to be 300 seconds plus 114.286 seconds, ending up with 414.286 seconds. Remember that for an AP calculus, you need to keep 3 decimals always for a number to take full credit of it. Well, now we should be able to move to the last point of the problem. And this last point, let's read it first. For the time between 0 and 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. Justify your answer. So I need to find out the people in line, but I need to justify also my answer. So let's see how can I do this. I'm gonna go back to my writing area. So let's put right here point D. Because I want to find out at what time the number of people in line was the minimum between 0 and 300, so the time is between 0 and 300 seconds, and I want to find out when the number of people represented a minimum on this. I need to use the extreme value theorem, so I'll be using the extreme value theorem. Let's see if we satisfy the conditions for the extreme value theorem. We have a quantity q of t, which was defined by, if you remember, q of 0 plus a of t minus e of t. A of t was integral from 0 to, so let me write it down, q of 0 plus integral from 0 to time t of r of x dx minus integral from 0 to time t of 0.7 dx. We can see that both this equation a of t and e of t are continuous functions, and they are differentiable, and therefore it means that I can use the extreme value theorem on the closed interval 0, 300. I have to check out at the ends of the interval and at the critical points of this function. So first, let's figure out the critical points for q of t. I'm gonna take the derivative of q of t, and I will solve that one and see when the derivative equals 0. Now, because this is a kind of a complex equation we'll end up with, I'm going to use the graphing calculator. But until then, let me write this one nicely here. So that will be the derivative of q of 0, that being a number 20, its derivative is going to be 0, plus the derivative of, let me write this one, derivative with respect to time of, I'm going to write as, compact this, integral from 0 to t of r of x minus 0.7 dx. Now, based on the fundamental theorem of calculus, part 1, I know that the derivative of this integral will be exactly the function right here. Obviously, the variable will going to be changed to t. So q prime of t is going to be 0 from here, plus r of t minus 0.7. So that's actually the equation whose graph I want to draw. I'm going to use my graphing calculator, and from the home menu, I'm going to switch to the graphing calculator. I need actually right here to write again that function. That's a complicated one, but let's do it. So I have 44 times, the first factor is a fraction. Let's try to introduce a fraction. I have some slow movement with my calculator now. So I'm going to use this fraction right here for the factor x over 100. So x over 100. And I know that is at the power of 3. And then I'll oops, not right there, down. I need to pull it down. So I'll multiply this with the last factor, which is 1 minus. And right here I need another fraction. Let's focus going a little bit faster this time, which has the numerator x and the denominator 300. The power this time for this is 7. And out of it, we should subtract, we should take 0.7. Well, I'm going to graph this function. And most likely I'm not going to see too much now, because the range of my window is not an appropriate one. Since I'm interested in the interval for x 0, 300, I have to change this range. So let's change the range. Window setting. I'll take between 0 and let's say 300. Usually it's good to take a little bit larger than that, but it's okay right here. And I'm gonna graph this function. Now I can see that here that's the derivative of q of t. So there are two critical values. Let me figure out those. From the menu, I'm going to analyze the graph. I'll pick up the analyze graph submenu and then figure out the zeros. The first value is a 33, and I need another one right here. So let's go the same way and pick up, then figure out again that the other intersections. There are 2 points, as you can see, 33 and second 167, where q prime of t is 0. So these are our critical values. Now, because these are the critical values, I need actually to write right here the critical values. So I have t1 is 33 seconds, and t2 it was 167 seconds. So these are the critical points. For q of t. The problem with these critical points is that probably one of them will be the point I'm interested in, or we have to check out first. So let's go back to the graph. Remember that the graph we have traced right here is that one of q prime of t. Now, for 0 to 33, q prime of t is negative. From 33 to 167, q prime is positive. Therefore, 33 is a point of local minimum. So let me write this one down. So I'll say for q prime of t is less than 0 for t less than 33, and q prime of t is greater than 0 for t greater than 33. It results that t equals 33 is a point for a local minimum. Let's see what happens with 167. If that's not a minimum, then I'm not going to waste the time to write anything right there. So I'm going to go on my graphing calculator, and I can see that to the left of 167, the derivative is positive, and then to the right is negative. It means that the function is increasing q of t up to this point, and then it's decreasing. So 167 is a local maximum. I'm not interested in that. Let's go back to our notes, and based on the extreme value theorem, I need to compare now the values of q of t at the endpoints. So for 0, which I know is q0, and it's 20 people. The value of this expression at 300 seconds, which I figured out it was 270 people. And I need to figure out q of 33. So for q of 33, let's remember what is the equation right here. At any time t is q0 plus integral from 0 to t of r of x dx minus integral from 0 to t of 0.7x, or maybe I can write it compact right there. So let's change this and rewrite the equation. Page 3 this time. The number of people at second 33 is going to be the number of people at time 0 plus integral from 0 through 33, and I'm putting together the number of people entering as well as the number of people exiting. So right here is r of x minus 0.7 dx. 33 equals 20 plus this integral. I'm going to use the graphing calculator to estimate the integral. I'm going to go to the menu and calculator menu, and right here from the submenu I'm choosing calculus and integral. If I want to find out that integral, let me see, did I define the function? No, I didn't define the function. So probably the easiest way first is to define the function and then to figure out the integral. So let's go right here and define the function, because otherwise we have to compute way too much. So action define. So I'll say r of x equals, and the equation I have to write it down, 44 times the first factor. Hopefully this is not going to take us 2 minutes. Okay, that was kind of fast. So the first factor is x over 100 to the power of 3, and now I'll multiply with the second factor, parenthesis 1 minus, and right here let's oh nice, I have x over 300 to the power of 7. Forgot to define this, I apologize. So let's compute it again. I forgot the definition, that's why. Integral from 0 through 33, and right here is r of x minus 0.7 dx. Okay, now it's perfect. So this is negative 16.1966. To this integral I need to add 20, such that I can figure out exactly what's the number of people at time t equals 33. And the problem says that I have to round to the nearest whole number. So going back to my notes, it means that I have to round to what? 4. So that will be negative 16.19 whatever 966, and I will take Q of 33 being about 4 people. Well, let's go a little bit back to where we needed those 3 measurements in order to figure out which one is the absolute minimum. At times 0, the number of people in line were 20. At times 300, oh, I think they were only 80. Why did I put 270? That was a mistake right here. And at this time, I got actually only 4 people. Okay, so that finishes our second part of the problem. Thank you.